In this video, we're going to learn about the reciprocal of a number. So what is a reciprocal? Well, the reciprocal of a non-zero number call it x, the reciprocal of x is equal to 1 over x. That's the definition of what a reciprocal is. To get the reciprocal of a number, you just have to take that number and put it in a fraction 1 over that number. So let's give a few concrete examples. For example, the reciprocal of 2 is just 1 over 2, or a half. Likewise, the reciprocal of 9 is just 1 over 9, or 1/9. How about the reciprocal of 1? Well, the reciprocal of 1 is just 1 over 1, which can be simplified to just 1. Yeah, that's right. 1 is the reciprocal of itself. And then how about a negative number? The reciprocal of, say, -3 is just 1 over -3, which can be simplified by pulling out the negative, just -1/3. Lastly, why does x have to be non-zero? Well, we could try to take the reciprocal of 0. Reciprocal of 0 is, using this definition, we could plug it in as 1 over 0. But this fraction is undefined since we can't divide by 0. So the reciprocal of 0 is undefined. We'll learn more about why this is in a future video. Okay, so how about fractions? Well, the reciprocal of the fraction a over b is given by b over a. You just have to flip the fraction. The numerator goes to the denominator and the denominator goes to the numerator. And of course this is provided that a and b are non-zero. Otherwise, if a were 0, then the fraction a over b would evaluate to 0, and the reciprocal of 0 is undefined. And if b were 0, then a over b would be some number divided by 0, and division by 0 is undefined. Okay, so now we have a rule for taking the reciprocal of a fraction, and why don't we do a few demonstrations of that rule? First of all, why don't we find the reciprocal of, say, 2/3. The reciprocal of 2/3, well, that just comes from flipping the fraction according to our rule. The numerator goes to the denominator and the denominator goes to the numerator. So the reciprocal of 2/3 is itself going to be a fraction, but this time the numerator 2 goes to the denominator. So denominator here is 2, and the denominator 3 goes to the numerator. So numerator is 3. So we just flip the fraction and there we go. 3 over 2, 3/2, that is our reciprocal. Okay, how about another demonstration? The reciprocal of, say, 1/2. What is the reciprocal of 1/2? Well, that just comes from flipping the fraction again. So the result is a fraction, the numerator goes to the denominator, 1 goes to the denominator, then the denominator goes to the numerator, 2 goes to the numerator. 2 over 1, and we can even simplify that further. 2 over 1, well, 2 divided by 1 is just 2. So the reciprocal of 1/2 is just 2. Alright, how about another demonstration? This time, how about with a negative fraction? How about the reciprocal of -5/9? Alright, so for a negative fraction, it works the same way. We just keep the negative sign. So keep the negative sign, and then flip the fraction part. So flip 5 over 9. So that just entails taking that numerator 5, moving it to the denominator, and then taking that denominator 9, moving it to the numerator. So -9/5. That is the reciprocal of -5/9. All right, last one. How about the reciprocal of a decimal? Well, the reciprocal of 0.6. What is that? We have a rule for taking reciprocals of fractions, but what do we do with a decimal? Well, one strategy is just to realize that a decimal is really just a fraction. So let's convert 0.6 into a fraction, and then we can use this rule for taking the reciprocal of a fraction. 0.6 as a fraction, well, that's just 6/10. So let's write that down, 6/10. And we can simplify this even further. 6 and 10 are both even, so divide top and bottom by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. 3/5. So 0.6 is just the same as the fraction 3/5. And now we can just take the reciprocal of 3/5. And to do that, we just have to flip the fraction. So just 5/3. So there we go. There is the reciprocal of 0.6. With all this discussion about reciprocals, why do we even care about them in the first place? What's so special about them? Well, the special thing about reciprocals is that if you take the product of a non-zero number and its reciprocal, the result that you get is always equal to 1. So the product of a non-zero number and its reciprocal is going to be always equal to 1. Why don't we give a few demonstrations just to solidify that fact? So for example, 3 times a third. 3 is a non-zero number, and a third is the reciprocal of that non-zero number, so the result should be equal to 1. And indeed it is. A third of 3 is just 1. Okay, so that was pretty straightforward, but what about this other example? -3/2 times -2/3. -3/2 is a non-zero number, and -2/3 is the reciprocal of that non-zero number, so does this come out to 1? Well, let's go ahead and compute it. It definitely should, so let's see that it does. So negative times a negative, whenever we have a negative times a negative, they cancel out and become a positive. So really we just need to compute 3/2 times 2/3. And let's go ahead and compute that. So 3/2 times 2/3, to multiply fractions, we can just multiply straight across. 3 times 2 is 6, over 2 times 3 is also 6. 6 over 6, and then 6 over 6, well, 6 divided by 6 is just 1. So the result is 1. So it checks out in both of these cases, and it will always check out. The product of a non-zero number and its reciprocal is always equal to 1. Now that we know the product of a non-zero number and its reciprocal is equal to 1, we can more easily answer questions like this. For example, if 2 times triangle just represents some number, so if 2 times triangle is equal to 1, then what is triangle? What number does triangle represent? Well, we know that the product of a non-zero number and its reciprocal is equal to 1. So here, 2 times its reciprocal equals 1, so triangle is just the reciprocal of 2. Let's write that down. Triangle equals reciprocal of 2. And what is the reciprocal of 2? Well, the reciprocal of 2 is just 1 over 2, a half. So triangle equals a half. The other example is pretty similar. It's a bit more of a word problem. If the product of -5/2 and a number is 1, then what is that number? Well, again, we just need to remember that the product of a non-zero number and its reciprocal is equal to 1. So if the product of -5/2 and some number is equal to 1, that number has to be equal to the reciprocal of -5/2. And the reciprocal of -5/2, well, let's go ahead and compute that. So keep the negative sign out in front, and then just take the reciprocal of 5/2. So just flip that fraction, -2/5. So that number is just -2/5. Great, so now we know how to find the reciprocal of a number, including fractions, and also apply that knowledge to solve some word problems. In the future, we'll continue to gain some practice working with fractions, such as simplifying fractions of fractions.